Okay, what's going on, guys? How you guys doing? In this class, we want to be talking about confidence interval for the population mean. All right. So this is quite a very vital aspect we have to clarify. It's very simple. Trying to explain the entire concept, and it's a range of value that is likely to include the population parameter at some certain confidence. So it's more like saying, let's say there's a range of value. Permit me to just use this to illustrate it. This is a particular value. This is another particular value. So a confidence is actually the range of value that is likely to include, that means your population parameter, that's the mean, will be in between this interval at some certain confidence. That means we can say at a 5% confidence, we are sure that our population mean will be within this interval. So it's just a range of value. The confidence interval is more like saying we are sure that the population mean will be between this value. Now, that means in cases like this, you would not know the population mean. Majorly, you would be knowing the sample mean. That's why I said it's calculated from sample data. So you always construct your your confidence interval from the sample mean. The confidence interval for the population mean is always constructed from the sample mean. This is just the simple formula for it. So let's assume I'm trying to find confidence interval. Let's use C high to denote that, all right? Confidence interval for the population mean, always understand that. And if you're going to find the confidence interval, this is all you need to do. It's just as simple as this. You want to say X bar. Of course, this is the point estimate. I'm sure you guys understand when I say parameter, talking about the measure from the population mean. And when I talk about the measure from the population, from the sample mean, I'm talking about statistics, or you can say this, for instance, now is a point estimate. You can say statistics, you can say estimate. Now, plus or minus what we call the margin of error. Now, this is the formula for finding the confidence interval for the population mean. All right, this is the formula I just wrote. Now, it's that simple. I'm just going to explain to you how to calculate majorly the E. Now, what's the E signifying there? The E right here is what we call the margin of error. Now, I want you to know that in some certain textbook, this may be written as EBM. You may see this word E written as EBM. What this stands for is error band for the mean. Error band for the mean. All right. So this is not popularly used. Majorly what you see being used is margin of error. But just in case you see EBM anywhere, understand that it's still meaning margin of both the same thing. All right. So this is the sample mean plus or minus the margin of error. Now look at how this looks like. Of course, you're looking for an interval. As I told you already, it's a range of value. So obviously, the meaning of this is that we'll be having our confidence interval will be something like this. X bar minus E. Then we have X bar plus E. So that means the range of value on the left, the minimum value will be X bar plus E. That we have a 90% confidence that our population mean will be between this particular interval. So let's take, for instance, we got this answer to be 20.5 and 30.3. So we'll be saying that we are confident that our population mean will be between this interval. All right. Now we're going to solve some examples, right? And look at this margin of error. Look at this margin of error. The formula for this is quite very simple. Z alpha over 2. All right. Sigma, of course, in this case, you have to know your your population standard deviation. You have to know this. So this is the formula for the margin of error. This is very, very vital to note. This right here, I want you guys to know that what we have here, sometimes some textbooks will write it as Z alpha, not Z alpha over 2. Well, I'm going to be telling you the reason why I would prefer to put it as Z alpha over 2, although many a times you may see it written as Z alpha, not alpha over 2. But I'll be showing you the reason for that in a moment. Now, but before I get into that, let me also identify to you that this formula right here, this alpha sigma over square root of n, is what we call the standard error. The standard error. All right? The standard error is sigma over square root of n. So, all right. So you can see now that we have the margin of error as the critical value, which I'm sure you guys know how to calculate this. We're going to just do it briefly. You guys already have to solve this. Multiplied by the standard error. The standard error is sigma over square root of n. Now, I want you to understand that this standard error sometimes comes out independently, and that's why I want you to note it. So you may be asked in an exam, especially an MCQ exam, to find the standard error. So you guys should note this quickly. This is how you find the standard error. Now, good. Let's get into an example very quickly. So obviously, let me just try and write this out now without breaking it down, and you guys can see how this formula could look like without all this. So if we're not going to simplify it this way, we can actually write the confidence interval as x bar plus or minus z alpha over 2 sigma over square root of n. All right. This is more like the formula. But in many cases, I will prefer you to know it this way, and then always identify that this right here is your margin of error, because there are certain questions that do come out where they will tell you to find the margin of error. So if you are told the margin of error, that's different from the confidence interval. You just need to go and find this alone. All right. So if you then want to use the margin of error to find the confidence interval, you would have to add and subtract that value from the sample mean. So that's just the way to find confidence interval. So let's look at a quick example right here. Let's say we have this question. I'll be reading it out. And I would prefer you guys paying real attention so that because we may not be able to write it out. Now look at the question right here. The average test score in a physics class is not distributed with a standard. Now look at it. The average test score physics class, that means the whole population here, the physics class, is normally distributed with a standard deviation of 5.4. In this case now, our standard deviation, the population standard deviation, is 5.4. All right. So, and then we have 50 scores. 50 scores with a sample mean of 79 were selected. 50 scores were now selected. 50 scores were selected. Obviously, the sample size here is 50. 50 scores with a sample size of 79 were selected. 50 scores, that means our n here is 50. And we said with a sample mean of 79, that means x bar is 79. I believe you guys have it in your notes, so you can just check it out there. Now, the question now goes like this. Find a 95% confidence interval for the population mean test score. That's question number A. Find the 95%, you have to find 95% confidence interval for the population mean. All right, so we are asked to construct a 95% confidence interval for the population mean. Question number 2 said, what is the value of the margin of error? So question number 2 asked us to find E for the margin of error. All right, not wasting time. Of course, one of the first thing I want to do is to just bring out the parameters as I've done right in front of us. Then I want to fix this up here. Anyhow you decide to find this, if you want to find the margin of error first, that's good. Probably let's do it that way. Let's try and find the margin of error first. So let's try and find the margin of error. Of course, this is the formula right here. Z alpha over 2 sigma over square root of n. So obviously I will be showing you how to find Z alpha over 2 very soon. But our sigma here is 5.4. Our n is square root of 50. All right. So this is what we just need to go find the critical value and then we'll be good to go. All right. We need to go find the critical value and we'll be good to go. Now, let me explain to you how to find the critical value. That's like, of course, that's very simple. I don't believe anybody is right here that wouldn't know how to find that. But let me just explain it for the sake of this particular class. To find the critical Z score, how do you feel now? Is it better? I'm trying to get the focus on is it better now? Some of you guys are talking about it being blurred. Okay. All right. Now look at something. If we're going to construct the 95% confidence interval, of course, you know we have our symmetry curve. Now, if we're constructing a 95% confidence interval, obviously, I'm sure you guys know that this will be 0.95, and you know this place will be 0.025, and right here will be 0.025. I don't believe there's anybody having struggles with this. So this is, we're constructing a 95% confidence. This is how you're going to be looking at the diagram as 95% confidence interval. So this is where your confidence interval lies in. All right. And here we have our alpha divided by 2, our level of significance divided by 2. All right. Now we have our Z table. You go on to find the Z score associated with an area of 0.025. Of course, if you find that out, you will get minus 1.96. Now, and due to symmetry, I told you guys already that obviously we're going to be having this other side as also 1.96. It just goes that way. So now we have gotten our Z score. So what you have to do right here to find the margin of error is to go on to fix the value 1.96 multiplied by 5.4 divided by square root of 50. All right. So that's just what you're supposed to do. And if you go on to do that, you should get a value of 1.4968. All right. That's just the way you go about this. And now you have gotten your margin of error, obviously, as 1.4968. But don't forget, we're supposed to construct a 95% confidence interval. So we now need to go on now. No, for the person asking, that was the reason why I knew you were going to ask that. You're not going to use the minus. When you are solving confidence interval, you don't use the minus version. You use just the 1.96. All right. Please take note of that. You don't make use of the minus. You make use of the 1.96. And this is why I said I wanted to, even though people do fix this place as alpha, But ideally, what actually happened wasn't alpha. So some textbooks and some materials, we use the value here to be Z alpha. This spot is not alpha. This is alpha over 2. So that's why I prefer using the alpha over 2 right there. So of course, it's just more like saying finding the critical value when you are dealing with 95% confidence. But again, the critical value, what you use to find the critical value, the area was the area for 0.025 on each tail. So that was why I prefer having it that way. Now let's try and construct the confidence interval. The confidence interval is quite simple. Nothing so much to do. Confidence interval, as I wrote right here, will be X bar. We're giving the X bar to be 79. That will be 79 plus or minus the margin of error, which was 1.4968. Now, if you go on to solve this, you should get a value of 77.5032. And 80.4969. So this right here is the confidence interval for your population mean. So this is how you just find it's quite very simple. I'm sure you agree that this is not something very, it's not a big deal. It's all about just understanding the flow of things. So our conclusion is that we are 95% confident that the population mean is between 77.5032 and 8969. So the meaning of this is that, look at, when we say we are 95% confident, this is the meaning of this. That means if we are to take 100 samples, if we take 100 samples, we are sure that 95%, 5 of those samples will have a mean between these values. Now, that may be complicated for some of you, but let me say one more time, probably you can grasp it. If you have the meaning of this result, can be interpreted as saying, if we had 100, now that, don't forget, we constructed this at the 95% confidence interval. Now, 95% here means if we had 100 samples, we take 100 different samples. 95 of those 100 samples will have their population mean in between this interval we just wrote here. Let me say that one more time. If we had 100 samples, 95 of them will have their population mean between these values. Of course, the remaining 5 of them may not have their population mean in between these values. So that's the interpretation of that. All right. Now let's solve a different question, and I would like you guys to make an attempt to this. Try and solve this before I give you the answer myself. So the question is, the average test scores in a chemistry class is normally distributed with a standard deviation of 6.5. So this is a different question. Now we have the standard deviation being 6.5. Now 100 scores with a sample mean of 82 were selected. 100 scores with a sample mean of 82. All right. This is a different question now. So we said the average test score in a chemistry class is normally distributed with a standard deviation of 6.5. 100 scores, standard deviation is 6.5. And then we said 100 scores with a sample mean of 82 were selected. So the X bar right here is 82. So the question is find a 90% confidence interval for the population exam score. So you have to find a 90% confidence interval. So we want to construct 90% confidence interval for the population mean exam score, So can you guys attempt that quickly? Of course, question number B said we should find a margin of error. All right. So guys, you can start to solve this. I would be solving mine also. And at the end, I would love us to have the same answer. So you can focus on yours and then to see if I'm going to have the same answer with you. So of course, I want to start to find the margin of error first because that's just quite easy. So I want to find the margin of error. That will be Z alpha over 2 sigma over square root of n. Obviously, whatever my Z alpha over 2 is, I know my sigma to be 6.5 and I know my n to be 100. Obviously, this will be 10. So I can write this as 10. All right. Now, I want to go on now to find my critical value, my Z alpha over 2. Now, in this case now, we're dealing with 90%. Of course, 90% will have a different Z value to that of 95%. So this is going to be 0.90. Now, this is going to be 0. The alpha there will be 0.1. Dividing 0.1 into 2, you'll be having 0.005. All right. Now you go on to your Z table, you go and find the critical value, the Z score that associated with this 90% confidence level. And obviously you'll be getting an answer of 1.645. So you get for this side, you get minus 1.645. You check this on your table. Of course, your negative table, you go on to look for the areas, the Z scores there with an area of 0.005. You'll be getting minus 1.64 and minus 1.65. But of course, as I told you, the distance being the same thing, you will be taking the average of both of them. That's how you're going to get minus 1.645. Now, due to symmetry, of course, if you want to find it manually, so you can still go on to find using your positive table, but in that case, you'll be looking for 0.905 on your positive Z table. Now, in this case, you'll be getting 1.645. So obviously, your Z value, your critical value in this case is 1.645. So you need to go on now to have 1.645 multiplied by what you have here. That's 6.5 divided by 10. If you go on to solve all this, you should get a value of 1.06925. So this is your margin of error. How many of you got this value as your margin of error? You got this value as your margin of error. Can you indicate in the comment section? So your margin of error for this particular question is 1.06925. All right. And you need to now go on to find your your confidence interval, which is quite very simple. What you have to do is to just go on to use this formula right here. So your confidence interval will be equals to X bar. Okay, I don't need to write that. My X bar is 82. 82 plus or minus your margin of error is 1.06925. So you go on to have 82 minus 1.06925. And that will be 80.93075. And then you go on to have 82 plus 1.06925, and you get 83 points. In that case, you get 83.06925. So this right here is the confidence interval for your, this is the 90% confidence interval for the particular question we're solving. So this is just how simple confidence interval for population mean is. It's not going to, let me give you a question quickly so you guys can get yourself solid in it before we go to our next topic. All right. So you can take this down quickly. I will not really be solving this, but I'll give you an opportunity to solve then. I will tell you the answer. So scores on an exam are normally distributed with a population standard deviation of 5.6. All right. Let me write the parameter here. Population standard deviation is giving us 5.6. Random sample of 40 scores on the exam has a mean of 32. A random sample of 40 scores means your N is 40. A random sample of 40 scores on the exam has a mean of 32. That means X bar equals to 32. So the question is, estimate the confidence interval for the population mean with the first one, solve for 80% confidence. Second one, you have to solve for 90% confidence. And the third one, I want you to solve for 98% confidence. All right, so you can start solving. The question is, scores on an exam are normally distributed with a population standard deviation of 5.6. A random sample of 40 scores on the exam has a mean of 32. Estimate the confidence for the population mean with 80% confidence, 90% confidence, and 98% confidence. So let me get your answer in the chat box quickly. So when you're done with an answer, let me know which confidence you're solving with. If it's 80%, let me know what the answer is. If it's 90%, let me know what the answer is. If you're here to give us a thumbs up, what are you waiting for? Give a very great thumbs up to this video. This class very soon, and then we'll be walking into the T distribution. As I told you guys already, we'll be having 2 different classes. So guys, once we are done with this video, you would check into the other video quickly so we can start that one. We're going to be starting T-test, student T distribution right in after this class. Let me get your results. What do you have for the confidence 80% confidence? What did you have? Or do we are you guys finding it difficult to calculate it? So because all you have to do here is fixing these values. So you have Z alpha over 2, your sigma is 5.6, and your N is 40, square root of 40. So you go on to find the value for 80% for Z alpha over 2. If you go on to find, this place will be 0.80, obviously, and you'll be having 0.2 on both sides. So we will be dividing it to get 0.1 and 0.1. In this case now, your Z value, you find, if you check this on your table now, you should get a value of minus 1.28 and 1.28. So you go on to fix that in here. This is me trying to find the, I told you guys to use the positive side of things, don't use the negative side. So you'll be using you'll be using 1.28, multiplying it with, this is what I call the standard error. I repeat that, this is the standard error plus the standard error multiplied by the critical value is what we use to get the margin of error. So in this case now, you'll be getting this value to be 1.13. So this is the margin of error for the 8% confidence. And what you have to do is to find a confidence interval you want to do. For the lower limit, we're having 32 minus 1.13. For the upper limit, you'll be having 32 plus 1.13. Right, this, I'm trying to find a confidence interval right here. So you'll be having 30.87 and 33.13. So the confidence interval, percent confidence is 0.87 and 33.13. That means we can say that with an 80% confidence, we know that the population mean will be between this value. As I said already, you can see this way that if you had 100 samples, you are sure that 80 of them will have a population mean between these values. That's a better way of actually saying it. That when you say 80% confidence, you got the confidence interval, the 80% confidence interval to be 30.87 and 33.13. You are now, the way to interpret that is to say that if you had 100 samples, 80 of them will have a population mean between these values. Of course, the other 20 will obviously have outside these values. So that's how you say it. Whenever you get, if you get for 90%, that means you're saying if you had 100 samples, 90 of them will have a population mean between the values you got, the interval you got. All right, that's the way, that's a better way of saying it. All right, what do you get for the 90%? Anybody got in for the 90% yet? So for that of the 90%, you should get a value of 30.54, 33.46. And for that of 98%, you should get 29.94, 34.06. All right. The values you should get should be actually these. If you don't get these values, please try check up your work. The margin of error for the 90% is actually 1.46. So the margin of error here was 1.46, whereas the margin of error for this 98% was 2.06. All right. So guys, this is where we're going to end the class for confidence interval. So we're going to be meeting at the t-test class. So guys, we'll be ending this video right now. So we'll be jumping into the other class. Thank you guys.